We've got some time for questions before our break. And the first one I have is for Ben, and this was posted by Cassandra Marion. How many people are in the room in the Apollo example you showed? Is Ben still with us? Maybe not. Can I get a comm check? Can you hear me?
Yeah, can you hear me now?
Yeah, I can hear you now.
Well, I'm really not having much luck today. Apologies.
No worries.
How many people were in the back room? Well, there were lots of people in the back room. The people you saw in the background of that footage were primarily support people for the LSAT experiments, and then also visitors. You saw some astronauts that would come in and out, and people that were involved in the planning, just checking to see how things were going. And I think, but it's important to know that people knew when they were supposed to be an observer versus when they could come in and start talking about what should happen on an EDA.
Great. The next question is also for you, Ben, and it's from Zachary Morse. He's curious as to what your thoughts are on documenting the Artemis missions. Should every team or room have a dedicated documentarian to capture and archive the audio and the visual data?
Well, that's a great question, but I know that my answer already is going to be yes. There has to be, because I'm very interested in the history of Apollo and I've done a lot of work there. But maybe an important point of view is that you might not need that documentation for the purposes of the operation of the mission, but that might turn out to then be later very important for historical reference and larger pictures that are being asked. So do it for posterity, not necessarily just because you have an immediate requirement to have it.
Great, thanks. Let's see. I've got a question here for Pat, and hopefully Pat is still with us. And the question is, do you have recommendations for scientific disciplines that must be represented in the science support team to make sure we are facilitating useful discussions, especially given the nature of Artemis with a focus on in situ resource utilization and those sort of issues?
Yes, and I think one of the carryover technologies and expertises that was mentioned in the context of the Mars rovers is one that hasn't been traditionally part of either Apollo or some of the subsequent simulations and support groups, but the interpretation of spectrometric data, for instance, Raman spectroscopy, for things like chemistry and composition. When you're dealing with a large pile of regolith or a large pile of pyroclastics, as at Schrödinger Basin, there can be internal variations in composition that could tell you something critical about the history. So I think part of an Artemis team, depending on where we go, could be a specialist in interpreting spectrometric data. It's beyond just, is this iron rich? Is it magnesium rich? But some of the subtler chemical anomalies. I think that would be a really valuable addition to a support team.
Great, thank you. I have a question for Jackie. And the question is, what are the potential bottlenecks in the structure of the MCC in terms of communication and decision making? And are there any situations where mission activities occur at a pace that might stress that system?
Let's see, that's a good question. Normally, the crew is ahead of the ground team. Sometimes the crew has to pause on orbit, which is not what we prefer. We want to keep them going since EVA time is valuable. And having the pre-planned responses really helps us flow through where we don't have those bottlenecks. We don't have that stop and flow back up to the crew members. One of the times that it is not, if we don't have it pre-planned and the teams do not agree in the backroom level, then we could have a bottleneck where one team wants to go forward with one action and another team wants to go forward with another. And then it has to go to the flight director for a decision versus the whole backroom team recommending the same path forward.
Great, thanks. Next question is for Alex. This is from Daniel Clements. The comment is, one of the interesting things I found working closely with EVA ops for ISS is that the EVA tasks are timelined and trained and certified separately from the EVA crew. And so will Artemis training need to be more aligned with the tasks, science, instruments, et cetera, of the specific mission rather than being sort of generic?
So we will do skills-based training to make sure that our crew members are, trained on a variety of skills that will be needed to execute lunar EVA. So that is imperative, and that's lessons learned from Apollo shuttle and station. That skills-based training is important. That said, task-based training on a specific task will be necessary for a specific lander, a specific payload, a specific science experiment or science instrumentation. So that type of task-based training will be required, and you'll get that specific crew with that activity. Now, to develop some of the training concepts and develop some of the EVA planning, we will have to use other crew members because our crew member size is not that large, and those assigned crew members are going to be busy doing other training and other operations like that. So currently, like right now, when we're doing operation concept development at a rock yard, at field sites and things like that, we are using a variety of crew members, a variety of engineers.
Great, thank you. The next question is for Ashvin. And the question is that you mentioned 500 scientists on the team. And how are that many people structured in terms of sub-teams? Can you talk about the organizational structure?
Sure. Yeah, it's definitely a lot of people. So one thing is that we have operational roles. Someone just recently mentioned there's certain people who know that they are just observers and others who speak on the microphone. We definitely do that. So we just have maybe 30 particular roles that speak on the mic any day. And those are people who are, like one per instrument sort of thing. We have a geological representative, an atmospheric science representative who speaks for then a wider section of the team under that particular discipline or under that instrument. We also have a whole lot of team members who just do the analysis of the research, of the data from the mission and don't participate directly in operations. So that 500 does break down into those groups.
Yeah, that is a lot to manage. Another question here for this time for Fred. The question is the term mapping. This is from Jim Skinner, by the way. The term mapping gets mentioned a lot, but means so many different things. Could you please clarify what kind of mapping you're speaking of when you say all things mapping?
It goes all the way from mapping from science for science purposes to mapping for engineering purposes. So we have the teams, the team that Ashwin was talking about. They've done an analysis, or they've done some, localizing of what the geologic outcrops are on the surface, and they need to transmit that to the team. So part of that is providing that in a format that others can see and look at and share, but also putting that into position in terms of engineering of where is the rover today? What is its location on the ground, on the mission base map, and how does that translate into science areas that are nearby, as well as areas of interest that we want to go to, campaign areas. And it also involves taking science instruments and localizing their science products, their results. The camera was pointed at AS34 elevation minus 17. Where does that intersect the surface? Do we have another science target that's near that location, and what does that result? So it's mapping at all those scales, and then it's mapping for engineering purposes, like, can I see a view shed over that hill? So it's all those. And I'll just give a quick example, like on the Perseverance, we need to know first where we landed. That needed to be transmitted immediately. then we had download descent images. We georeferenced that and then shared that with the science team so they had a better view of the surface. That was given to the heli people to see if they could find a good airfield to put the helicopter down and display it. And then all that fed into the maps for the science team to say, oh, we want to drive east, we want to drive north, we want to drive south, for the next move of the rover. And all those require maps. All those requires knowing your position. All those requiring knowing how all your instruments are located on the ground. So it's mapping at all those levels from science all the way to engineering and the translation between the two.
And I would just add, it's also imperative from a safety standpoint. We're going to the South Pole, and precision navigation is important because I can see my lander that's half a kilometer, even a kilometer away. I have line of sight, but I don't know what the hazards are in between it because of these long shadows. And so I applaud people that keep emphasizing precision navigation.
Well, thanks to both of you for that answer. I think we're out of time for questions now. The next item on the agenda is a break. So we'll reconvene here at 25 minutes after the current hour. So that's 2:25 Eastern time. So in a little bit, less than 12 minutes from now. Thanks, everybody.